look at your MT7 LT1 seminar and graphing systems of equations. That's what we're going to be doing most of this chapter if you haven't figured that from your pretest. First thing I want you to do is do the first 5 questions and then come back and continue on with the rest of the seminar. What I want you to do today is I want you to determine the number of solutions from a system of equations. I want you to solve them by graphing. And we're going to solve just plain old equations by graphing. And we're going to use our graphing calculators, Desmos, to do a lot of this work. Now, first off, when we have a system of equations, we have 2 lines. Those 2 lines could cross or they could not cross. And so what happens is we can have one solution, infinite solutions, or no solutions. If you have an answer, we're going to say that's consistent. So that is one of the key vocabulary words. Consistent means you have an answer. A consistent equation that has one answer is independent. So what happens is if I have a graph and I graph 2 lines and those 2 lines intersect, that is going to be independent and consistent. Consistent because it has an answer, independent because we have 2 separate lines. Now, if I have 2 lines, but one is exactly on top of the other. So let's draw one like that. You can see that. So and I'm not very good at drawing, so we'll kind of go with that. So what happens is I've got this line, and then I take my red line, and it goes exactly on top of it. So everything that's a solution to the blue line is a solution to the red line. Everything that's a solution to the red line is a solution to the blue line. It has a solution, so we say it's consistent. But because one depends on the other, we say it's dependent. It has more than one answer. It has infinite answers. It's either one answer or infinite answers, and you're not going to have 2 answers or 3 answers when we come with lines. When you go to Algebra 2, that'll be a little bit different. Now, if we take a look at inconsistent, that means they don't cross. So what kind of lines don't cross? Hopefully, you told me parallel. And that's exactly what's going to happen. I'm going to have 2 lines here. They're never going to cross. So we say they're inconsistent. Yes, they are independent because they're 2 lines, but we usually just say inconsistent. But if they get asked, they are independent because we've got 2 lines. Now let's take a look at a problem. I just want to know if it's consistent or inconsistent, if it's independent or dependent. Okay, so if we look at the first one, notice it has an answer, so it's consistent. We have 2 different lines, so it's independent. This one does not have an answer, so it's inconsistent on example 2. And we're going to say it's independent because we have 2 different lines, but inconsistent pretty much tells you that, but we'll write it that way because I think that's what your textbook wants. Okay, now, what happens if I don't have a line? I just have the equations. Well, look at this one. I've got the same slope, don't I? But my y-intercepts, they're different. So these lines are parallel. If they're parallel, they're inconsistent. And they're independent. So we're going to do the same thing in example 4, except on example 4, notice we've got to do a little bit of work. We have to get y by itself. So In the first case, I think what I'll do is I will add 6x to both sides. So then I'll say 4y equals 6x plus 16. Then we'll divide by everything by 4. Y equals 6 over 4. I can reduce to 3 over 2x. And 16, I didn't draw my 16 very well. 16 divided by 4 is 4. Now I'll do the same thing on my second line. First thing I'll do again is I'll add, well, I will not add, I will subtract 9x from both sides. So then I'll get negative 6y equals negative 9x minus 24. So I'll divide everything by a negative 6. So I'll get y equals a negative divided by negative is a positive, so we get 3 over 2x plus 4. Oh, look at that. They're the same, aren't they? If they're the same, we say they are dependent because they're the same line. They do have an answer, so it should say consistent. Consistent and dependent, or dependent and consistent, the order doesn't matter. That's what they are. Now, I can solve an equation by graphing, by just graphing each side of my equation. That makes it kind of cool, a lot less work to do. We'll do that in the next part of the video.